All right, ladies and gentlemen, welcome to the fifth and final video in the series here for Chapter 8, Section 4, which introduces SOHCAHTOA as a method for solving right triangles, finding missing side lengths and missing angle measures. In this video, we're going to discuss how to use two side lengths to find a missing angle measure. So our variable will be our angle measure. You will only use inverse trigonometric functions to find angle measures. So please note that this approach will only be used when your variable is an angle. Now, when I say inverse trigonometric functions, I'm talking in general about inverses because, when we're solving an equation, we are always using inverse operations. For instance, to undo addition, we subtract. To undo subtraction, we add. To undo multiplication, we divide. To undo division, we multiply. That's how we solve equations. So what we're running into is a situation where our unknown, our variable, is inside of one of our three trig functions, sine, cosine, or tangent. In order to get rid of the sine, cosine, or tangent function in an equation, we need an inverse. These functions are named the arc sine, which is the inverse of sine, the arc cosine, which is the inverse of cosine, and the arc tangent, which is the inverse of tangent. Now on your calculator, these buttons are usually the same buttons as sine, cosine, and tangent, but you have to either hit shift or second to access them. It's usually written directly above each button, and you'll see the notation sine to the -1. That is not an exponent. That is mathematical notation for inverse, indicating that you have accessed the inverse sign. So, let's take a look here at some examples of this. I think there's a total of 4 in your note packet, and see how we use this. This is actually less labor intensive than when we end up with our variable in the bottom of our equation. So here we go. Here we have example 4, solve for the angle measures marked with X in each triangle. Round your answers to the nearest tenth of a degree. So we're going to round to the nearest tenth, which is 1 decimal place. So just like we did when we were finding missing side lengths, we're working with one of the two acute angles. It's the one marked with X. So based on that, we named the sides that they gave us. The 14 is across the triangle, which makes the 14 the opposite side. And the 8 is right next to it, but it's not the hypotenuse, which makes it the adjacent side. Well, just like we did before, we're going to write an equation. So we look at SOHCAHTOA. And we determine that since we have the opposite and the adjacent side, that this is a tangent equation. And we write a tangent equation. The tangent of our unknown angle, x, equals opposite over adjacent. Now remember that when we solve an equation, we're trying to get the variable by itself. So we need to get rid of the tangent function. Well, to get rid of the tangent function, what we do is we take the inverse tangent of each side. I'm getting a little bit cramped because I already drew my line, but that's okay. Okay, so when we take the inverse tangent of each side, we're looking at the inverse tangent of the tangent of x equals the inverse tangent of 14 over 8. Now what happens is the tangent and the inverse tangent cancel each other out because they're inverse functions, and we're left with x. So x is equal to the inverse tangent of 14 over 8. So on the calculator we use in our class, the keystrokes here would be to hit second and then tangent. Now your calculator, if you're not in my course, might be a little bit different. It might be a shift button instead, but it's generally those keystrokes. You've got either a shift or a second button, then you hit tangent. And then within that tangent to the negative first, we're going to type in 14 divided by 8. And you should get in the habit of closing those parentheses, and then you're going to hit your enter button. So, the inverse tangent of 14 over 8, we hit second tangent, 14 divided by 8, and we get x is approximately 60.25. Now this time we're rounding to the nearest tenth, so we look at the 100th digit, which is a 5. That tells us to round our answer up to 60.3, and in this case x is an angle, so we give it a degree measurement, 60.3 degrees. Let's do another example. So here we're working with this angle, again marked with x. 23 is on the hypotenuse, and 16 is across the triangle, making it the opposite side. So we go to SOHCAHTOA to figure out which trig function we should be using, sine, cosine, or tangent. We are dealing with opposite and hypotenuse, which makes this a sine problem. The sine of our angle marked x is equal to 16 over 23. Once again, we are inside of a sine function. To get it out of the sine function, to free it from the sine function, we are going to take the inverse sine, or arc sine, of each side. So the inverse sine of the sine of x equals the inverse sine of 16 over 23. Once again, when we do that, the sine and the inverse sine cancel, and we are left with x is equal to the inverse sine of 16 over 23. We're going to type that into our calculator, second sine, and put in 16 divided by 23, which gives us 44.07. The 7 tells us to round the 0 up, meaning our answer should be 44.1 degrees. Now there are 2 more examples of this, so again you should pause the video and try the other 2 examples on your own, and then resume the video to see how you did. Example 5, our last example in these notes, has the same directions as example 4. We're being asked to solve for the angle measure marked with x in each triangle. We're rounding our answers to the nearest tenth of a degree. So we start off here, we've got angle x is what we're working with, 9.5 is on the hypotenuse, 3 is next to our angle, meaning it is the adjacent side. We look to see which trig function we should be using SOHCAHTOA. Because we are relating adjacent to hypotenuse, this is a cosine problem. So we set up our equation. The cosine of x is equal to adjacent over hypotenuse, 3 over 9.5. We then are going to take the inverse cosine of each side, the arc cosine of each side, in order to get x by itself. So we have the inverse cosine of the cosine of x equals the inverse cosine of 3 over 9.5, or the arc cosine. Remember that the cosine and the arc cosine on the left will cancel each other out. X is the inverse cosine of 3 over 9.5. We're going to feed that to our calculator. Second cosine, 3 divided by 9.5, is 71.59. Remember that 9 tells us how to round. We're going to round that 5 up to 71.6 degrees. On part B, we are dealing with the bottom angle here, marked x. 6.2 is the hypotenuse, 4.4 is the adjacent. Once again, we're going to set up and look at a SOHCAHTOA to figure out which trig function we should be using. This relates, I'm sorry, that's not adjacent, that is opposite. There's my first mistake of the video. It's across the triangle from x, that is the opposite side, not the adjacent. So we have opposite and hypotenuse, which means we are using the sine function. The sine of our angle x is opposite over hypotenuse, 4.4 over 6.2. We take the inverse sine of each side. So the inverse sine, or arc sine, of the sine of x equals the arc sine of 4.4 over 6.2. Remember that the inverse sine and the sine cancel each other out, leaving us with x is equal to the arc sine or inverse sine of 4.4 over 6.2. We feed that to our calculator. Second sine, 4.4 divided by 6.2. And we get 45.20. Again, the 0 tells us we're going to round down, meaning our answer is 45.2 degrees. Thank you very much for your time and attention through these notes over Chapter 8, Section 4, Introducing SOHCAHTOA to you for the first time. Good luck on your classwork. Remember that it's due on Monday. Thank you.